SoftwareStack. The software stack provides the services necessary to implement applications on top of the hardware. This is a typical HPC software stack, so you will have performance monitoring, development tools, libraries, management of resources and job scheduling, parallel file systems, and everything you need to run to manage the hardware. So usually you have some OS level elements in the stack, some runtime system, and some developers tools. Usually the runtime system is here to make the link between the OS level services and the developers tool. So for instance, the runtime system may provide some thread management for the compilers. For everything to go well, and that is to get good performance, you need the different pieces of the software stack to work in a consistent way. So for instance, assume you have two parallel applications, 1 and 2. They have each two processes, P1, P2, and P3 and P4. And P1 and P2 synchronize regularly when they are, and the same things for P3 and P4. That means if P2 is stuck waiting because it's not computing, for instance, P1 has to wait. If the scheduler allocates the processes in such a way that P1 is on core 1, P2 is on core 2, P3 is on core 2, P4 is on core 3, because core 2 is shared between P1 and P3, this will, because of the synchronization, slow down P1 and P4. So in the end, the machine won't be running very fast, and core 1 and core 3 will be waiting a lot for core 2. A better allocation would have been to put P2 here and to leave P3 in here. In that case, application 2 would be fast. Application 1 would not be faster, but at least the resources would be better exploited. Questions. List the interactions that may happen between the software stack elements. What issue do you see when running multiple applications simultaneously on multi-core? References with two examples of stacks, and see you in course.